Let me take you somewhere most analysts never go. Not to the war rooms of Washington, not to the shouting matches on cable television, not to the oil futures trading floors in London where nervous traders were watching Brent crude cross that psychological $100 barrier this week. No, let me take you somewhere quieter, somewhere that smells of synthetic resins and industrial precision, somewhere that hums with the sound of carbonization furnaces operating at temperatures that would make steel weep. Let me take you to the actual front line of the great 21st century power struggle, a factory floor in China, where something happened this week that the mainstream commentariat almost entirely failed to notice. And here is the paradox of our time. While the world was glued to images of smoke rising over Tehran and oil tankers navigating through a half closed Strait of Hormuz, while politicians and pundits debated the geometry of yet another Middle Eastern catastrophe, China was quietly, methodically, and with characteristic patience doing something that will shape the next 50 years of human civilization far more profoundly than any drone strike or missile barrage. On March 11th, 2026, China National Building Material Group, known as CNBM, unveiled a material called the T1200. They also designated it SYT80, but let us stay with the T1200 because that name carries a specific gravity that demands attention. A carbon fiber, the world's strongest mass-produced carbon fiber to be precise, a material with a diameter smaller than 1/10 of a human hair, a density barely 1/4 that of steel, and a tensile strength approximately 10 times greater than ordinary steel. They revealed it not just in a Beijing press conference, but simultaneously at JEC World, the global composites industry show in Paris, France. In Paris, in the heart of old Europe. That is not an accident. That is a message. That is Beijing telling the world, and specifically telling Washington and Tokyo, that the age of Western material supremacy is over. Now we are getting to the most surprising part of this story, and I want you to understand why this matters before we go any further. This is not a story about a better tennis racket. This is not about lighter bicycle frames or more aerodynamic Formula One cars, although the T1200 will eventually show up there too. This is a story about who controls the physical substrate of military power in the 21st century. This is a story about the invisible material that goes inside hypersonic missiles, next generation fighter aircraft, autonomous underwater vehicles, space launch vehicles, satellite constellations, and humanoid robots designed for battlefields that do not yet officially exist. This is the story of a 50-year technological siege that China just conclusively won, and most people on the planet had no idea the war was even being fought. To understand what happened this week, we have to travel back to the 1970s, to a laboratory in Shanxi province at the Institute of Cold Chemistry of the Chinese Academy of Sciences, a group of Chinese scientists working with almost no reference materials, no international collaborators they could legally consult, no access to the proprietary processes that Japanese and American companies had spent decades perfecting, began the slow, painstaking work of learning how to make carbon fiber from scratch. They were crossing a river by feeling the stones, as the Chinese expression goes. Every reactor, every spinneret, every carbonization furnace, all designed and built domestically because no one was going to sell them the real equipment. China was, from the very beginning, fighting this particular technological battle completely alone. The reason for that isolation requires a small detour, but it is an essential one. Carbon fiber at high performance grades is not just an industrial material, it is a strategic asset of the first order, classified in most Western export control regimes alongside semiconductors and weapons guidance systems. The grading system itself, the T number system that gives us T300, T700, T800, T1000, T1100, and now T1200, was originally defined by Toray Industries of Japan, the company that dominated global high-performance carbon fiber production for decades. The higher the number, the greater the tensile strength, and exponentially greater the manufacturing difficulty. And the critical insight, the one that Pentagon planners have known for decades, is this: you cannot build a modern military without access to grades T700 and above, the skins of stealth aircraft, the nozzle throats of rocket engines, the pressure vessels of submarine systems, the structural frames of hypersonic glide vehicles. All of these require ultra high strength carbon fiber. And for the better part of 4 decades, Japan and the United States controlled roughly 90% of the global supply of the high end grades. The detail nobody talks about, but that decides the game, is what happened every time China tried to get this material through other means. In 2012, a Chinese national was indicted in a New York federal court for attempting to procure Toray high-grade carbon fiber on behalf of Norinco, China's largest state-run weapons manufacturer. He had worked through brokers who approached Toray directly in Japan. Toray said no. The New York company they were redirected to turned out to be a front operation run by U.S. Immigration and Customs Enforcement. That arrest was not isolated. In 2011, an entity called Prime Technology was caught trying to smuggle Toray M40 and M60 grade fibers to the China Academy of Space Technology. In 2013, a man was caught attempting to arrange 5 tons of T800. 5 tons. That is not a laboratory experiment. That is an industrial procurement program. These were nodes in a systematic, state-directed effort to acquire by any means possible a material that the West had decided China could not legally have. And so China did what China always does when it is told it cannot have something. It spent 20 years building the capability to make it better than anyone else. The real breaking point starts right here in that timeline. In 2005, the Chinese state handed the Institute of Coal Chemistry a national mission: develop aerospace-grade T300 carbon fiber in 3 years. Their Japanese counterparts had taken 15 years to do the same. Under conditions of extreme pressure, working hours that would have broken most academic research groups, the Chinese team delivered. China became the 3rd country in history, after Japan and the United States, to independently produce aerospace-grade carbon fiber. That was 2008. The T300 was the bottom of the high-performance ladder, but it was the beginning of a relay race that spanned generations of scientists, each one handing off to the next at a higher level of difficulty, each cohort building on foundations laid at enormous personal cost. From T300, China moved to T700. From T700 to T800, from T800 to T1000, and from T1000 to the T1200 unveiled this week. Each step on that ladder represented not just a material science achievement, but an entire ecosystem of supporting technology built from zero. The precursor fiber, the raw polyacrylonitrile-based thread from which carbon fiber is ultimately made, had to meet quality standards of almost unimaginable precision. The carbonization furnaces had to be domestically engineered because no one would sell China the foreign equivalents. By 2024, China's demand for carbon fiber accounted for more than half of global consumption, and more than 80% of that demand was being met by domestic production. The import substitution revolution in carbon fiber was, by the midpoint of this decade, essentially complete. But the completion of that revolution did not stop at sufficiency. It overshot into dominance. The T1200 has an engineering tensile strength exceeding 8 gigapascals. Ordinary structural steel operates at roughly 0.4 gigapascals. High-strength aerospace steel might reach 2 gigapascals. The T1200 operates at 8. That is not incremental improvement. That is a categorical change in what is physically possible when you build a structure out of this material. And here is the detail that separates this week's announcement from every previous milestone in China's carbon fiber journey. This material has achieved industrial-scale mass production at a capacity of hundreds of tons per year, not laboratory samples, not pilot batches, industrial production. The factory is running. The supply chain is operational. Japan's Toray had announced development of a T1200 grade fiber back in late 2023, but Toray has not revealed its production capacity. That silence is telling. In the world of advanced materials manufacturing, developing a material in the laboratory and actually producing it at scale are separated by a chasm that has swallowed entire research programs and industrial ambitions. Scaling up production of T1200 is extraordinarily challenging. The precursor fiber must meet quality standards so stringent that minor deviations in the polymerization process render entire batches useless. The carbonization stage, where the precursor is transformed at high temperatures in a precisely controlled atmosphere, demands equipment stability that is extraordinarily difficult to maintain at the 100-ton per year throughput that CNBM has now achieved. The fact that China got there first, not just in development, but in actual mass production, is the headline. The fact that almost nobody in the Western press treated it as such is the subtext. Now we are getting to the most surprising part of this story. Consider what a material with 10 times the tensile strength of steel and 1/4 the density means for spacecraft design. China's commercial space company Light Technology has already developed a liquid rocket called the Weiguang-1, whose body structure is approximately 90% carbon fiber composites, reducing weight by 25 to 30% compared to metal designs. At the T1200 performance level, those weight savings become even more dramatic. In the constellation satellite market, where China is building its own equivalent of Starlink with hundreds of planned platforms, lighter structures directly translate into lower launch costs, higher payload fractions, and faster deployment timelines. In the domain of military aviation, the implications are even more direct. High-performance carbon fiber at T1200 grade enables airframe structures that withstand higher aerodynamic loads at lower weight, meaning longer range, higher speed, and greater maneuverability for the same engine output. The next generation of Chinese fighter aircraft, the platforms that will define the balance of air power across East Asia through the 2030s and 2040s, will be built with this material, the pressure hulls of advanced unmanned underwater vehicles, the structural frames of hypersonic re-entry vehicles, the rotor systems of next-generation vertical lift platforms. All of these benefit directly and immediately from the T1200 breakthrough. But the application that deserves special attention, the one that most geopolitical analysts have not yet fully absorbed, is humanoid robotics. CNBM explicitly named humanoid robots as a target application for the T1200. That is not an afterthought. China is investing massively in humanoid robotics for manufacturing, logistics, and, let us be honest about the direction of this technology, eventual autonomous systems applications. A humanoid robot built with T1200 carbon fiber components is lighter, stronger, and more capable than one built with conventional materials. At the scale of millions of units, which is the scale China is targeting for its robotics deployment programs, the material advantage translates into a generational gap in capability that cannot easily be closed by countries that do not have access to equivalent supply chains. The detail nobody talks about, but that decides the game, is the phrase CNBM Chairman Zhou Yuxian used in his announcement: fully independent and controllable capabilities across the entire industrial chain. The entire chain: precursor production, carbonization technology, winding equipment, composite manufacturing, from the raw polymer all the way to finished structural components. This is supply chain sovereignty in its most complete form, and it is the definitive answer to decades of Western export control strategy. The Western export control architecture was built on a theory of coercive interdependence. Keep China technologically dependent on Western supply chains, and you maintain leverage over Chinese strategic behavior. The theory was not irrational. For a period, it worked. China had to scramble, had to resort to procurement operations that ended with people being arrested in New York hotel rooms, had to advance more slowly and more expensively than it otherwise would have. But the theory contained a fatal flaw. If you tell a country with China's resources, state capacity, and historical memory of technological humiliation that it cannot have something, you do not prevent that country from getting the thing. You guarantee that it will eventually make the thing itself and likely make it better than you did. This is the pattern that has repeated itself across every domain of the technology competition between China and the West. Semiconductors, artificial intelligence chips, quantum computing, high-performance batteries, now carbon fiber. In each case, the export control mechanism provided a short-term delay and a long-term accelerant. The restrictions forced Chinese institutions to develop their own capabilities rather than licensing foreign technology, which meant that when they finally broke through, they owned the entire intellectual property stack. They were dependent on no foreign licensor. They were not subject to any foreign supply disruption. They had built, at enormous cost and over enormous time, a completely self-contained technological ecosystem. And that ecosystem is now, in domain after domain, operating at or beyond the frontier that the West once monopolized. The real breaking point starts right here in what this means for the global South. For the vast majority of the world's nations, the countries of Africa, Latin America, Southeast Asia, the Middle East, the emergence of China as a full-spectrum carbon fiber supplier operating at the technological frontier changes the entire calculus of defense procurement, aerospace development, and industrial modernization. For decades, these countries were dependent on American and Japanese suppliers for advanced composite materials. And those suppliers operated not just as commercial entities, but as instruments of geopolitical leverage. The Chinese alternative was present but limited, fine for wind turbine blades and sporting goods, but not credible for serious aerospace or defense applications. That calculus is now fundamentally altered. A country in the global South that wants to develop its own aerospace capability now has a credible non-Western supplier operating at the highest performance grade in the world. The non-aligned movement was always a political aspiration. Now it has a supply chain to go with it. Now we are getting to the most surprising part of this story because the T1200 announcement arrived in Paris, of all places, at JEC World, the International Composites Industry Exhibition, attended by engineers and executives from Boeing, Airbus, Lockheed Martin, Mitsubishi, and every major player in the advanced materials world. CNBM walked into the Parc des Expositions and said, in the most polite and professional language possible, we have arrived. Not just as a competitor, as the leader. The reaction in the composites industry was carefully subdued. Western aerospace companies are in an extraordinarily awkward position. On one hand, they need high-performance materials at competitive prices. On the other hand, geopolitical pressures make meaningful commercial engagement with Chinese advanced material suppliers politically untenable for most Western prime contractors. Boeing will not be sourcing 1200 from CNBM for its next aircraft. But the fact that the Western industrial base is being simultaneously priced out of competition in mid-range grades and surpassed in ultra-high-strength segments creates a strategic problem that no amount of export control legislation can solve. Consider the institutional structure that made this possible. CNBM is a state-owned enterprise operating on planning horizons aligned with national strategic priorities, not quarterly earnings cycles. It has access to patient capital from state banks. It has guaranteed procurement from state-linked aerospace entities. When Joe Yuxian says his organization has achieved fully independent and controllable capabilities across the entire industrial chain, he is describing a system of governance capable of sustaining 70-year industrial missions without losing strategic focus. This challenges foundational Western assumptions about the superior efficiency of market-based systems. The T1200 is, among other things, an empirical verdict on two competing models of industrial development. In this particular domain, at this particular historical moment, the Chinese model delivered results the Western model could not. The detail nobody talks about, but that decides the game, is where this goes next. Joe Yuxian said his team would continue pursuing even higher grades. The T1200 is not a destination, it is a waypoint. The entire industrial chain is in Chinese hands, the research institution is operating at the frontier, and state funding shows no sign of contraction. The applications are already propagating through China's industrial ecosystem in ways that will take years to fully manifest. The commercial space programs, the humanoid robotics platforms, the next-generation aviation programs, the high-speed rail expansion running through the 15th five-year plan. All of these are now served by a domestic materials supply chain operating at world-leading performance levels. And while all of this was unfolding, the world was watching oil prices and a war with no exit ramp. That is the nature of crisis. It fills every screen, every headline, every analytical bandwidth. But crises resolve. The Strait of Hormuz will eventually reopen. The fires will eventually be extinguished. And when they are, the material reality of global power will be exactly what it was when the fires were burning. China, with the world's most advanced carbon fiber industrial base, operating independently at scale, serving every strategic sector of a civilization that has been systematically building toward technological self-sufficiency for half a century. The Roman Empire was not undone in a single battle. Its erosion was material, structural, and slow. A decline in the quality of its institutions, a debasement of its currency, a loss of the organizational capacity that had once made it capable of building roads and supply chains across 3 continents. The Tang dynasty at its height was not merely militarily powerful, it was the world's greatest manufacturing civilization. Its silk, its ceramics, its metallurgy, all expressions of a material sophistication that no contemporary civilization could match. The Belt and Road Initiative is, at its core, a 21st century attempt to rebuild the physical infrastructure of Eurasian connectivity that the Silk Road once provided, this time with Chinese standard equipment, Chinese grade materials, and Chinese designed supply chains running through every node. The T1200 is not separate from that project. It is the material expression of its ambition. There is a final irony in all of this that deserves to be named clearly. The Western export control regime designed to prevent China from acquiring high-performance carbon fiber was motivated by a recognition of exactly how strategically critical this material is. Washington knew, Tokyo knew, Brussels knew. They knew that whoever controls the supply of ultra-high-strength carbon fiber controls a critical choke point in the production of military and aerospace power. And so they built walls, they ran sting operations, they constructed elaborate legal architectures. And the result of all that effort, all that legal machinery, all those prosecutions, all those export license denials was to produce 50 years later a China that not only has the T1200 but has the entire industrial chain to produce it independently, at scale, forever. The walls did not stop China. The walls built China's capability. The walls were the mother of necessity, and necessity, as it always does, produced the most important inventions. And so here is where we have to sit with a question that has no comfortable answer. If the strategic purpose of Western technology controls was to maintain technological superiority, and if the empirical outcome of those controls was to accelerate Chinese indigenous development to the point of global leadership, what does that tell us about the theory of technological competition that has guided Western strategy for the better part of a century? Was the strategy wrong? Was it necessary but ultimately insufficient? These are not rhetorical questions. They are urgent, practical ones for everyone currently designing the next generation of export controls around semiconductors, artificial intelligence, quantum computing, and biotechnology, domains where China is following an eerily similar trajectory to the one it followed in carbon fiber. I want to leave you with one image to carry with you. In a laboratory in Shanxi province more than 50 years ago, a group of scientists with almost no reference materials, no foreign assistance, and no guarantee of success began feeling their way across the technological river, stone by stone, in the dark. They could not see the other bank. They could not know if they would reach it. What they had was patience, state support, and a collective memory of a century in which their civilization had been on the receiving end of other people's technological superiority, and the absolute determination that this would not continue. This week, 50 years later, their successors stood in Paris and showed the world what they had built. It was thinner than a human hair, stronger than steel, and invisible to every news algorithm busy tracking oil prices and missile trajectories. It was the most important thing that happened in the global technology competition this week. It happened quietly. It happened in plain sight. and it will be shaping the world long after the current fires are extinguished and the next crisis has already begun. Stay curious, stay informed, and see you in the next episode.